So the velocity of particles are like this, and the separation between them, let it be 4 meter. So I want the angular velocity of A with respect to B. At one instant, the velocity of particles A and B are like this, and the perpendicular distance between them is 4 meter. Now I want angular velocity of A with respect to B. So actually particles, are they moving in circular path? This is the best question I am asking you. A and B are moving in some plane. How B will move? In xy plane. What about A? A will move in minus x minus y plane. Are you getting? So B will move in first quadrant. A is moving in the third quadrant. Sir, they are not in circular motion. And how can you ask like that? Yes, I can ask. Are you getting? No? So it's not that something they should move in circular path. So I'll write the question. The particles A and B are moving in a plane. I'm not using no way circular motion. Huh? They're moving in a plane as shown. Find the angular velocity of particle A with respect to B. Getting the idea? So this will be really troublesome for you. So they are not moving circular path, how you brought it. Okay, let's go for omega AB. I'll calculate. So it should be equal to VA minus VB. So 6 root 2 cos 45. I think anything I'll direct it like this. I'll take it positive. Minus of minus 10 sine 30. Now why negative sign? 10 sine 30 will be in that direction, thereby perpendicular distance between them. So which components you should take? Those components which are directed perpendicular to line joining the particles, they will determine angular velocity. So 6 root 2, this will be 6 minus of minus, this will be plus 5 by 4. So 11 by 4 radians per second. And now your task question, sir, what about direction? What about direction? What we are discussing, angular velocity of A with respect to the B is what the reference, no? So it should be, shall I put direction here? Will I agree all of you? You have taken just B as reference. See, like getting confusion, sir. Like you do one thing. If particle moves like this and B is at rest, then you say angular velocity like this, no? Here. Now B is also in motion. So angular velocity of A with respect to B. B is at rest here, no? If B is in motion, then it will be like this. This will be really troublesome for students, but just stick on to the basic definition. So they are moving in a plane, you are telling no way that circle word you brought it. So where do they can ask you this? Relative velocity in projectile motion. Two projectiles thrown, angular velocity of one projectile with respect to other projectile. At, at minimum separation, find the angular velocity of one projectile with respect to other projectile. See, linked problems. Are you able to analyze? I can link. Okay, fine. So now we'll go for the next one. This is very, very popular. Just only the definition, if you know it, I think you can manage. No very big concept. So let's have that. Let me take two particles. The same concept what we studied now, I'm going to extend it. I'll go to the next page. Okay, let the particles move in a circular path. So there's a particle B or particle 2, I'll write it. Or B will write it. So it is moving in circular path. So angular velocity and the radius vector is RB, and the other particle